So in the previous demos, we've seen how to create partitions. We've created shards using local databases, and then we pushed out the data for those partitions to the shards. That was part one. In part two, we looked at schema migration. So how do you deal with adding or dropping a column with those shards present? And now in this demo, we look at how to deal with what CytosDB calls reference tables. So how do you deal with tables that you can't shard or you don't want to shard? And how do you get them or make them available on shards? So we're basically facing the problem that we look at one of the shards, it is pretty much empty. So there are, apart from the tables, from the partitions, there are no other tables available. So this is not really useful. We can't go to the shard and run queries that touch the issues table and then join the users table, for example. And assuming that we can't shard users table in a similar fashion, then perhaps we might want to have that as a reference table on the shard as well. So what we can do here is apply logical replication, basically replicate the users table from the main database into the shard database. How does that work? We go to the main database, and then we basically set up logical replication, obviously. We can look at wall level that's set to logical, that is important. And then we create replication slots for both shards, basically. So this is 2 replication slots for logical replication. And then we basically publish the tables that we're interested in. And in our case, just call it test publication. I'm going to use tables users, maybe also projects. Now that those tables are published, we can go to a shard. Let's take shard 1 in this example. And then we basically tell it to subscribe to the subscription or subscribe to the publication, basically specifying the main database connection string. So this is my local database. This is the main database. Using the publication that we just created and using the logical replication slot we created. This is a workaround. If you omit those, it's not going to work if the replication source is on the same local database, because it sort of hangs in that situation. And then you resolve that by creating the replication slot ahead of time and then telling it not to create that slot in the same time it creates the subscription. And then we run into the issue that this table does not yet exist. So before we can actually create that subscription, we're going to create the empty tables on the shard for projects and for users. So let's do that over here. So we have this reference table script, basically just taking a schema dump from projects and then also from users and applying that to the shard 1 database. There's a bunch of errors because there is references to other tables that don't exist. So, but that's okay for now. So let's retry creating the subscription, and that worked. And now we can basically look at the tables in the public schema. We should see projects and users. And now after creating that subscription, those are being populated from the main database. And now we're basically replicating all the changes from the main database into those 2 tables. So we can easily select from those tables. We see the same content as in the main database. Same for the other table, of course. We can do the same thing on the second shard, but that's probably not terribly interesting. It's the same kind of thing. Now what this means is we can actually join between, we can go to a shard and run a query that joins between one of the reference tables, or maybe even more, and also join into the partitions that reside on the shard. So looking at the partitions that we have on this shard, there's 4 of them. We could do things like selecting from one of the parts, one of the partitions, joining the, let's say, users table. For example, on the author ID, something we have, I think. And we can do things like this, right? Of course, there's a missing schema here. And there we go. Now we have we basically joined the reference table across with the one of the issues partitions, and we're basically selecting the issues title and the username over here. Taking this one step forward, what would be interesting is to not have to deal with those individual partitions here. So typically we have, in the default schema, we have a issues table, right? We don't care about partitions, and none of the queries explicitly specify a partition. I have sort of a half-baked approach of dealing with that. We could, for example, create the main table again. So this is the one that we have by default. And let that look like one of the partitions just to get the same schema. Now this resembles the same schema as everywhere else, right? We have the same indexes. Now, what we can do here is to basically attach the individual tables that we have on the shard and attach them to this main table. This is basically the way the old Postgres partitioning worked. Like, we use table inheritance for that. So we can say alter table, one of the partitions, and let that inherit the main table, right? And after we've done that, and we've also applied it to the other partitions, we can basically work with the original main table, and we basically see all the content of the attached partitions. What that means is now that we have the main table back, what we can do in our join query is we don't care about the specifying the individual partition anymore, but we can just use the standard table for that. And that's still going to work. Obviously, that only hits the tables or the partitions that are attached to this main table. And we are also on a shard, so on the shard 1 database, and that means we don't have all the issues available. So only, like in our case, we only have half of the partitions available on shard 1. So looking at the public issues table, that's only going to give us like half of the actual data that we have. Now, this could be useful if we knew that some data exclusively lives on shard 1, or the data we're interested in exclusively lives on that shard. So what we could do is, if we had a project ID, maybe let's figure out which one this is. This is 1. So if our query join users and issues comes in with a project ID equals 1 footer, we know that this data is exclusively on shard 1, so we could go directly to this shard and then run this query and then basically make use of those attached partitions to the main table and then actually get the same data. It's a bit of a half-baked idea because what is basically missing for the old style Postgres partitioning is that we're missing the check constraints. So looking at one of the partitions, and I've played with this around before, so this happens to have one. You want to have check constraints on the partitions such that the constraint exclusion can work in partitioning. So basically, when you come in with this project ID, it's basically going to figure out what the right partition is to look at. This is why we have to add those check constraints to the partitions such that we can statically understand which partition that we have to look at. Now, the problem with that is those partitions, they basically resemble, or their data resembles what we created earlier in the main database using the declarative approach. And what's kind of interesting with that is we look at the how the partitions are set up. We'll see that we have 8 partitions, and there is we can specify modulos and a remainder. Problem is that this is based on the project ID, but it's actually based on a hash of the project ID, and this is something that is not readily available. So we would be able to say that a certain partition has or we would be able to formulate the check constraint at the moment. So we would have to include this hash function to make that work, but perhaps that's something we can figure out. So that's a bit, I find a bit mind-boggling, but something, yeah, that's perhaps interesting to think about.